Okay, so obviously in the chapter of percents, we've been talking a lot about percents lately, and then things, of course, that have to do with percent in real life. And yesterday, right, we talked about, for you guys, 2 days ago, our last lesson was on tax, tip, and markup. Okay, and that was all in one particular lesson because it all was very similar in one way. And that way is that the prices, for what different reasons, always increase. They went up in price. Okay, well today it's going to be a little different. It's more of what, as consumers, as customers, that we like, and that is, we like to see this right here, and that is discount. So that actually is our very first word, ladies and gentlemen, discount. Everyone? Discount. All right, so here's what your book says a discount is. It's the amount by which the regular price of an item is reduced. The amount by which the regular price of an item is reduced. Okay, over in your little box over to the side, here's what I want you to put. The discount is the money you save. It's the money that you save. Basically, the money that stays in your pocket that you don't have to normally put out, like if you were to pay the original price for something. Okay? So the money that stays in your pocket, that's the discount. Okay? The next word is markdown. Everyone? Markdown. So here's what your book says a markdown is. The amount by which the regular price of an item is reduced. Yes, it is the same. Hopefully that looks familiar to you because it's the definition we just had. Because the markdown, if you go to your box over to the right, is a discount. Markdown and discount. So if you see that in your lesson today, you'll understand what they're asking for. So the markdown and discount are the same thing. Okay, now what I have found over the years is people will see a discount, but there's another phrase out there that when it pops up on the lesson, students start getting it confused. The two of them confused with each other. And they think that they know what the difference is between the two, but sometimes they don't. It's an assumption, and it ends up being confusing. So what I'm going to do is I'm going to spend a little bit of time explaining the difference between the two. All right. So the one word is discount. Now here's the other word. Now for whatever reason, even though it's all over the book, they don't make it like a formal vocab word. Okay, so what you ought to do, it's not in your vocabulary sheets there. Go ahead and flip it to the back page. All right. All right, so we've had discount, right? Well, here's the other word that some people will get confused with discount, and that is sale price. Everyone? Sale price. So here's what a sale price is. It's the selling price. We talked about what a selling price is, right? The total cost. It's the selling price of the item after the discount, after they've taken off some money because of the discount.
The selling price.
So the sale price is the selling price of the item after the discount. So what you're going to find here in a second is that the discount and the sale price, you could say, are like complements to each other. If you don't know what I'm talking about, I'll show you here in a second. Now, just a little reminder definition, or a little reminder phrase. What a deal. All right? Your sale price, of course, is more than likely going to be, of course, better than the original price. You're getting a deal on it because of the discount, right? So the sale price is the deal you're getting. Basically, it's the money you're paying on a deal like that. All right, so now here's what I want to do. Okay, stay on the back side of your notes there. Okay, I'm going to introduce something new to you. It's like a graphic organizer, and I know you guys probably do some graphic organizers in maybe an elementary school, maybe even in an AB class. We haven't done a lot of them in here, but we're going to get more into it as our math gets a little more challenging. Okay, because sometimes graphic organizers will help us, some of us anyway, see the problem in a different way. Okay, and it'll help it make a little more sense to us. All right, so here's what I want you to do. Just trust me for a second. Go ahead, take your pencil, and we're going to write a box. And that box is all it is the long skinny rectangle. Okay, This is going to be called, I'm going to introduce to you a box diagram. And it can be used on a number, you're going to find this year, it's going to be used on a number of different types of problems, but this is one of them, a box diagram.
Does it have to be big?
Okay, so this box here, okay, some people will call it a bar diagram or box diagram. Okay, I'll call it a bar diagram for this. Okay, this does not represent a candy bar or anything. It's just, like I said, a way to sort your thoughts. So here's what I want you to do. Okay, I want you to go from the left side to the right side. Here's how we're going to show this. Go up above it and draw. It's kind of like a measurement from the left side all the way to the right side. The whole thing. With today's lesson, that whole thing is going to represent the original price of whatever item we're talking about in whichever problem. The original price is represented by the whole bar. That's the original price. Now, I'm going to kind of create a little story that also will help this bar diagram make a little more sense, okay? So lately, right, in one of our other lessons, our previous lesson, I talked about like going to Walmart and getting a great deal on a shirt, a t-shirt. And so here's what we're going to do. I'm going to keep the numbers kind of easy for you, but let's say that we go to Walmart and get a t-shirt, all right? I'll even put down here, and I'm putting it in parentheses just because this is just a little easy little imaginary story here, like an example problem. And that t-shirt, this whole price, which is the original price of this shirt, we're going to say is $10. It's $10. Now, here's what I want you to know. The original price of any word problem, in this case the t-shirt that's $10, is considered this whole bar, which is all of it, which is 100%. Right? The whole thing is always going to be 100%. The whole thing of anything is 100%. It's all of it. So the whole bar is 100% of the bar, which is, in this story, $10 for this t-shirt. And that is represented by the original price. Right? So the original price of this shirt is $10. That's 100%. Now, we're going to do something here in a second, and we're going to dive into this a little deeper. But before I do, are there any questions understanding what I just wrote? There's three major pieces of information. The whole thing is the original price. The whole thing is 100%. And in this story, the whole thing is $10. It is all one thing. 100% is the original price. And that original price is $10. Any questions about that? Okay, now here's what I want you to do. Go ahead, go inside the bar for this problem, and let's go to the left, go in just a little bit, and draw a line. You're basically splitting the bar into two separate littler bars. A little bar and then like a medium-sized bar. Okay, now here's what I want to talk to you about. I want you to go ahead and I want you to put a line from here to there, this little section right here in this bar diagram. In this problem, I'm going to draw a little arrow down here. In this problem, that little part is going to represent, if this whole thing's the original price, this little part is going to represent the discount. The discount, right? The money that we save. This is going to be the discount. Now, let's say this discount, we go to buy this shirt, the price tag says $10. The little, on top of the little rack there where all the shirts are hanging, there's a little special thing. It could be like in red or something, and it says 30% off. Okay, it's the big sale. It's 30% off. Our discount then, ladies and gentlemen, is 30%. 30% of the bar, or 30% of the original price. That's the discount. Now I use some easy numbers here to kind of make this make sense, okay? So the discount on this shirt is 30%. Does anyone know, using just some mental math, what that would be in money? What is it? $3. Yeah, $3. Good job. The discount, ladies and gentlemen, is 30% off, which is $3. So on this bar diagram, I want to point some out just like I did a second ago, right? For example, the original price is the whole bar. So its original price is 100% of the price. In this case, it's $10. The discount can be represented as a percent, the 30% off, and as the amount that you're saving, which is $3. Okay, remember the discount that's $3 is not how much a shirt's now going to cost you. Okay, that's the money you're saving. That's the discount. That's the $3. Now, I want us to go back here from this line that we already created. Go all the way over. So from there to all the way to the right, meaning the rest of the bar. That's going to represent, if this little part represents the discount, does anyone know what this part of the bar represents?
What you paid.
It's what you paid, which is in here
70%.
the sale price.
70%.
If this is the discount, this part is the sale price. So some of you guys are already thinking ahead. So the discount has two parts to it. It has the percent and it has the dollar amount. Okay? The sale price is also going to have a percent and also have a dollar amount. But look at this. If this whole bar is 100% and the discount's 30%, what's the sale price percent?
70.
70%. You guys see how that works?
Yep.
If this whole bar is $10 for that shirt, which is the original price, if the discount's $3, how much is the sale price? $7. Now I want to state the obvious, but sometimes it's not obvious because our brains are thinking in different ways. But I want to come back to this, and here it is. If the discount's 3 and the sale price is 7, obviously you add them to get the original price of the shirt. Or you could say if the original price is 10 and the discount's 3, you subtract them to get the sale price, right? Or if the original price is 10, sale price is 7, you subtract those to get the discount. Okay? However, some of us will probably go, okay, yeah, whatever, Ms. Wilkins, I understand. But some of us don't understand this. The percents work the same way. Your discount percentage plus your sale price percentage is always going to equal 100%, because the original price is always 100%. So if the discount was 50%, what's the sale price going to be? Percentage? 50%. If the discount percent was 25%, what's the sale price going to be? 75%. You see that? So this plus this is always going to equal 100%. Or of course 100% minus one of them is always going to be the other. Okay? I'm going to come back to that because we're going to need that idea when we get to our lesson. Now I also want to give you guys a heads up. In our lesson, we're going to use the same thing we've used the last couple days, and we're going to talk about a percent equation. Now I want to talk about this also, and you're going to see this. You have to understand, if I plug in the 30% into my equation, you have to expect you to get the discount price. If I plug in the sale price percentage, when I solve my equation, I'm going to get the sale price. I am not going to plug in.
Interruption. Victoria Lozado, please report to the Rayburn office. Victoria Lozada, please report to the Rayburn office.
All right, guys, sorry. Here we go. Refocus. If I plug in the sale price percentage, I am not going to get the discount price. I have to plug in the discount percentage to get the discount price. I'm going to come back to that. I just want to show you guys that because the equation is very picky. It's going to give you a correct answer if you do the calculations right, but it's going to give you the correct answer that these are linked together and these are linked. So we'll talk about that more in just a bit. What I want you guys to do right now, though, is of course grab your book and let's get started on some examples. All right, go ahead and take your book and flip to page 162. 162. Eyes up here whenever you're ready. All right, eyes up here when you're ready. Okay, so let's go ahead. We're going to start on page 162. Let's take a look at problem number 1. All right, let's close read that as a matter of fact. Here we go. Problem number 1 on 162. It starts with where it says Mary. All right, here we go. Mary and Roberto. We all with us? Okay, let's try this again. Mary and Roberto bought identical at different stores. Mary's backpack originally $65 and was
Discounted.
25%. Roberto's backpack cost $75 and was on
Sale.
for 30% off of the
Original.
price. Which backpack was the better buy? Explain. Now listen, first of all, pretty large problem, a few different steps. I'm going to break it up for the sake of this lesson, so please listen. Okay? Here we go. First, I am going to talk about how we would go about solving this, right? We're going to find out what Mary's backpack cost her after the discount was taken off and we get her sale price, and then we're going to go ahead and find out what Roberto's backpack cost them after we take off the discount and find the sale price. And then, of course, to find out what the better buy is, we're going to compare the two. But the reason why I put part 2 here is for the sake of the start of this lesson, we're only going to focus on finding Roberto's price of his backpack to start with. Okay? So here's what I want you to do. Let's go ahead, all right, and let's go ahead and write down our notes. Step 1. Now, step 1, this is getting more and more important. Okay, I've kind of built up to this here, lesson by lesson. But step 1 is I want you to write down our percent equation. Remember, part equals percent times the whole. Okay? Now, if I reread this problem, it says Roberto's backpack originally cost $75. I'm going to stop there. Remember what we talked about with the bar diagram? Okay? The original cost is the whole bar, meaning it's the whole. Right? It's 100%. So the original cost of this backpack is going to go where the whole is. And if it's $75, we're plugging in $75 for the whole, because it's the original price. Now, it goes on to say it was on sale for 30% off of the original price. Guys, 30% off, is that a discount or a sale price?
Discount.
It's a discount. If it's coming off of the original, that means it's a discount. So what I'm going to do is first I'm going to plug in the percentage of our discount, which is 30%. I moved my decimal over twice, right? 0.30 or 0.3. And here's what I'm going to do for step 2. This is step 2, by the way, right? I'm going to put a star here because, again, like yesterday, we're going to have a lot of things going on. You need to make sure you keep track of what you're finding here. Since we plugged in the discount percentage, I'm going to put D here for discount. The part is going to be the discount that we're finding out. Have that written down? Okay, step 3. And this is, of course, what we've been doing, right? At this point, we're going to simplify or solve depending on how our equation's built. In this case, it's all on one side. It's just the expression on the one side. I'm going to go ahead, take my calculator. 0.30 times 75 equals, and I end up with 22.5, 22 and 5 tenths. Okay, step 4. Remember, make it look like money. So we do that in a couple of different ways. Put our dollar sign, and of course round to the nearest tenth. In this case, I'm sorry, the nearest cent. In this case, it doesn't have a cent, so we're gonna put a cent there, 0 cents, right? $22.50. Now, here's the issue. This being equal to D means that, so reminder, this is the discount. Okay? It's not at, we don't want to, that's not our final answer for Roberto's backpack. We want to know how much did the backpack actually cost him. So guys, what are we doing with the $22.50? We are subtracting it from the $75. That's what a discount's all about. So that's step 5. Right? The previous lesson, our last lesson, had tips, tax, markup. We were doing a lot of adding because it increases the price. Discount's the complete opposite. So I take my $75 and I'm going to subtract it by $22.50. So do a little borrowing here. 0 minus 0 is 0. 10 minus 5 is 5. 4 minus 2 is 2. 7 minus 2 is 5. Decimal comes straight down. Of course, bring down that dollar sign. And guys, Roberto's backpack is $52.50. Okay, questions about that? Okay, here's what I want you guys to try out. Okay, I'm actually going to keep you going on the same problem. I want you to find out the same way I found out Roberto's. I want you to find out Mary's cost of her backpack. All right, the cost of Mary's backpack in the same problem. All right, I'll check in with you guys in about 1 minute. All right, go. All right, how many of you are still working on her backpack? All right. Give you about 30 more seconds and then we'll share. Okay, 30 seconds. Go ahead and turn to your neighbor and share. Go.
I got Mary's backpack cost, hers was a better buy. I got $48.70.
Okay. Here we go. Make sure you're checking your work. All right, I'm going to move part 1 up over here. Okay. So, talking about Mary's backpack, right? We're going to go ahead and follow the same steps. Part equals percent times the whole. I'm going to go ahead and do step 2, plug in the numbers. I need to be careful of what I'm plugging in. Mary's backpack originally cost $65. So the original price, meaning the whole, is $65. It was discounted at 25%. So they're giving us the discount percent. So I plug that in as a decimal. So 0.25, 25 hundredths. Now because this is the discount percentage, I'm putting discount here. So now when we solve this or simplify it, I'm going to go ahead and find out what the discount is. So 25 hundredths times 65 equals 16 and 25 hundredths. Or in this case, making it look like money, is $16.25. Now I just done up through step 3. Step 4, actually I did as well, making it look like money. Step 5, that's the discount, right? I need to find out, it's asking what is, well, it's implying that it's asking what is her sale price, right? How much did she buy it for? So I'm going to go ahead, take my $65 that the original price of the backpack is, take off her discount, which is subtracting her discount. So $65 minus $16.25 equals, and I get $48.75. And guys, that is Mary's bag. So we don't have to answer this because this isn't part of your homework, but if it asks which backpack's the better buy, I'm looking at the 2 prices, and which one's the better buy, guys? Mary's. So you just, and it says explain, so you would just say Mary's is the better buy because she's paying $48.75 while Roberto's paying $52.50. You're just stating what you solved. Okay? All right, questions about that problem? Okay, here we go. Let's move on to the next type of problem. Let's go ahead and take a look on 163 at problem number 3. So look at your homework. Okay, here we go. We have step 1. Okay, well, before step 1, it says find the sale price to the nearest cent. But look what they have. A $7.50 admission. 20% off is the discount. But they have sales tax. A little bit of review from yesterday. So, here's what we're going to do. Okay? We have to find the sale price. Let's pretend like this is we're going to the movies. So step 1 is we need to find out what the sale price of the movie ticket is. So I'm going to go ahead, write down part equals percent times the whole. The original price of the movie ticket on there says it's $7.50. So I'll plug in 7.50. It's 20% off. So I'm plugging in my decimal version of my percent, 20%. Remember, this here is the discount, changing P to D. So when I solve it or simplify it, I'm going to go ahead and put 0.20 times 750 equals, and here's what comes out, 1.5. Which if I make this look like money, it's $1.50 is the discount. Now don't forget, that's the discount, not the price of the ticket, right? So I need to then take my ticket price, which is $7.50, subtract my discount, just like we were doing with the 2 backpacks just a second ago, and I get $6. Now this is a little different than before. Here's what I want you to do. Put a little star by the $6, because that is our new price that we're going to work everything through. Okay? We're finding the sales tax of $6, not of the original $7.50. We're finding of the sale price. So here we go. Step 2 is exactly that. Let's find the sales tax. So part equals percent times the whole. The whole is now $6. The sales tax I'm plugging in, the directions say it's 5.75%. So if I move the decimal over, it's 0.0575. That is, I'll put T for tax, for the sales tax. So the sales tax, if I multiply these two out, $6 times 0.0575 equals, and I get 0.345. Making this look like money, put my dollar sign, and remember I need to round to the nearest cent. 5 makes the 4 go up, and our sales tax, guys, is 35 cents. Now comes step 3. Let's find out what the total is. So again, be careful, don't grab your $7.50. Your new price is $6. I add on our sales tax of 35 cents. And what is our total, everyone?
$6.35.
$6.35. All right. So it's kind of like yesterday. It's like 3 major steps, just using the same little bitty steps that we used up above. Okay. Questions on that problem? The problem said it was 5.75%. So you just move the decimal over 2 times. Okay. Guys, other questions? Okay, we do have one more problem to do. So, here we go. Let's take a look at problem number 9 on page 164. All right, let's close read the directions. Here we go. 164, problem number 9. Find the... Okay, let's make sure we're together. Let's try it again. Find the original
price
to the nearest cent. Look at number 9 says the calendar has a discount of 75%. And it says that the sale price, it says, is $2.25. Okay, now listen carefully. Here, there's an issue here. They're giving us the discount percentage, but look at, they're giving us the sale price money. Remember we talked about that? You cannot plug in the sale price percentage or the discount percentage and expect to get the sale price. Those are 2 different things. So this is where a couple little twists come in. So listen carefully. Here we go. Step 1 is we're still going to go ahead and write our part equals percent times a whole. But now you've got to be extra careful. I'm actually putting 2 stars by step 2 because I have to be so careful. So, first, the discount is 75%. The issue is the sale price is $2.25. Ladies and gentlemen, what if the discount percentage is 75%, what's the sale price percentage? Here's what I'm asking. If the discount is 30% here, the sale price was 70%. Let's go back. If the discount percentage was 75%, what's the sale price percentage? 25%. Remember we talked at the beginning of the lesson, they both add up to 100%. So listen, what I'm going to do is the sale price percentage is what I'm going to use. I'm going to plug in 25%. Why? Because I have to use the sale price, 2.25. You say, well, but Mr. Wilkins, wait, what about the whole? Remember what the question asks? What is the original price? And we now know the original price is the whole. So, step 3, remember I said we're going to simplify or solve? Well, this is one where we have to solve, meaning we have to divide both sides by 25 hundredths. That way, the whole, which is the original price. I go ahead and put 2.25 divided by 0.25 equals, ladies and gentlemen, the original price was $9. So, step 2, be very careful on those kind of problems because there's 2 little twists there. You have to find out for the original price, and you have to also plug in the correct percentage.